11th problem, y of t equal to modulus of x of t. Bring the given question in the standard form of system operation. Y of t equals to modulus of x of t is equal to system operating on the input signal x of t. Linearity. System operating on the input signal a into x1 of t plus b into x2 of t is equal to, so how it defines system operating on the input signal is equal to modulus of input. In case of linearity, input is a into x1 of t plus b into x2 of t. Therefore, modulus of input. This is LHS. RHS. A into y1 of t plus b into y2 of t is equals to a as it is. What is y1 of t? Modulus of x1 of t plus b as it is. What is y2 of t? y2 of t is equal to modulus of x2 of t. Comparing LHS and RHS, both are not equal. System is non-linear. Time invariant. T of x of t minus t naught. System operating on the input signal is equal to input signal only is equals to modulus of input signal. Modulus of input signal. In case of time invariant, input signal is x of t minus t naught. This is LHS. RHS, y of t minus t naught is equal to, y of t is given, I have to obtain y of t minus t naught. Replacing t by t minus t naught. Modulus of x of t minus t naught. RHS. Comparing LHS and RHS, both are same. System is time invariant. Next, memory. The present value of output depends on only the present value of the input. Therefore, the system is memoryless or static. So here the present output only depends on the present value of the input. Therefore, the system is memoryless or static. Casual. The present value of the output does not depend on future value of the input. Already I explained the present output only depends on present input, which indicates present output does not depend on future input, and the system is casual system. Stability. For the bounded input bx greater than or equals to magnitude of x of t less than infinity, for this bounded input, if applied for the system, then the system produces bounded output or not. How to calculate that output is a bounded or not bounded? I have to get the magnitude of y of t. Magnitude of y of t equals to magnitude of modulus of x of t. So already we know that modulus of x of t is a bounded bx, hence magnitude of bx is also bounded. Hence the system is stable system. 12th problem. Y of t equal to cos of x of t. Bring it to the standard form of the system. Y of t equals to cos of x of t, that is equal to system operating on input signal x of t. So the problem is defined. System operating on the input signal is equals to cos of input signal. In case of linearity, t of a into x1 of t plus b into x2 of t. This is a input signal, that is equals to cos of input signal. Cos of a into x1 of t plus b into x2 of t. This is LHS. RHS. A into y1 of t plus b into y2 of t. Y of t is given. y1 of t equals to cos of x1 of t. y2 of t equals to cos of x2 of t. Substitute this y1 of t and y2 of t here, we will get this equation. This is RHS. Comparing LHS and RHS, both are not equal and the system is non-linear. Go for time invariant. System operating on the input signal x of t minus t naught. T naught is not defined in the problem, hence we can consider t naught here. This is equals to cos of input signal. Cos of input signal. In case of time invariant, input is x of t minus t naught. Say this is LHS. Out RHS. Y of t minus t naught equal to, y of t is given, y of t minus t naught we have to obtain. T will be replaced by t minus t naught. Cos of x of t minus t naught. This is RHS. Comparing RHS with LHS, both are same. The system is time invariant. Go for next memory. The present value of the output depends on present value of the input. Y of t, this is x of t. Present value of the output at t equals to t depends on present value of the input at t equals to t. Therefore, the system is memoryless. Casual. The present value of the output does not depend on future value of the input. Therefore, the system is casual. Stability. For the bounded input bx greater than or equals to magnitude of x of t less than infinity, then the magnitude of y of t is equals to magnitude of y of t equals to magnitude of x of magnitude of cos of x of t. So as we know that cos of bounded value, always the cos of bounded value is in a bounded, because cos function always, magnitude of the cos function always between 0 to 1, hence the output of y of t is also bounded and the system is stable. Once again I will explain. Always the cos function magnitude value of the cos always varies between 0 to 1. Therefore, here cos of x of t is a bounded, cos of any bounded value will be gives a bounded value and its value varies between 0 to 1 and the system is stable system. Go for 13th problem. Y of t equals to sin of 6t multiplied with x of t. Bring into the standard form of the system. System operating on the input signal is equals to sin of 6t multiplied with the input signal. In case of a linearity, system operating on the input signal is equals to sin of 6t multiplied with input, sin of 6t multiplied by input. In the input here in the linearity, a into x1 of t plus b into x2 of t. Expand this one, a sin of 60 x1 of t plus b into sin of 60 x2 of t, LHS. RHS, a into y1 of t plus b into y2 of t is equals to y1 of t equals to sin of 60 into x1 of t, y2 of t equal to sin of 60 into x2 of t. Substitute this y1 of t and y2 of t here, you will get this equation is called as RHS. Comparing LHS with RHS, both are same and the system is linear. Next property, time invariant. T of x of t minus t naught equals to system operating on the input signal is equals to sin of 60 input signal. Sin of 60 input signal. What is the input signal in case of time invariant? X of t minus t naught. Say it is LHS. RHS, y of t minus t naught equal to t will be replaced by t minus t naught. T will be replaced by t minus t naught. T will be replaced by t minus t naught. Sin of 6 of t minus t naught x of t minus t naught, that is equal to sin of 60 minus 6 t naught x of t minus t naught. Comparing LHS and RHS, both are not equal and the system is not time invariant, which means system is time variant. Go for memory. The present value of the output depends on only present value of the input. Present value of the output at t equals to t depends on only the present value of the input at t equals to t and the system is memoryless. Therefore, the system is casual system because the present value of the output does not depend on future value of the input and the system is casual system. Stability. For the bounded input bx greater than or equal to magnitude of x of t less than infinite, then I have to calculate the magnitude of y of t. Magnitude of y of t equals to magnitude of sin of 60 x of t. Expand magnitude of sin of 60, magnitude of x of t is a bx. So bounded into sin function. Always sin function magnitude always varies from 0 to 1. Hence bounded into bounded is also bounded and the system is stable system. 14th problem, y of t equal to x of sin t. Bring into standard form of system. Y of t equals to x of sin t is equal to system operating on the input signal t of x of t. System operating on the input signal is equals to input signal only x of t only, t will be replaced by sin of t. In linearity, system operating on the input signal a into x1 of t plus b into x2 of t, that is equals to input signal only in which t will be replaced by sin t, a into x1 of sin t plus b into x2 of sin t, LHS. RHS, a into y1 of t plus b into y2 of t. Y of t is given, I have to calculate y1 of t. y1 of t equals to x1 of sin t, y2 of t equal to x2 of sin t. Substitute here y1 of t and y2 of t, we will get a into x1 of sin t plus b into x2 of sin t, RHS. Comparing LHS and RHS, both are same and the system is linear. Time invariant. T of x of t minus t naught. System operating on the input signal is equals to input signal only, t will be replaced by sin of t. System operating on the input signal is equals to x of t only, t will be replaced by sin t. Here also same thing, x of t minus t naught, t will be replaced by sin t, x of sin t minus t naught, this is LHS. RHS, y of t minus t naught equal to, y of t is given, I had to replace t by t minus t naught, therefore x of sin of t minus t naught. RHS, comparing RHS and LHS, both are not equal and the system is non-linear. Next property, memory. System depends on present value of the input or past value of the input or future value of the input. Here see that the present value of the output depends on past and future value of the input and the system is memory or dynamic. Example, take a t equal to 1, y of 1 equals to x of sin of 1. Sin of 1 value is a 0.841, therefore x of 0.841. The present value of output y of 1 at t equals to 1 depending upon the past value of the input t equal to 0.841 x of t, t value is 0.841, output t value is 1, and the present value of the output depends on past input. Take another example. At t equals to minus 1, y of minus 1 equals to x of sine of minus 1. Sine of minus 1 value is minus 0.841, therefore x of minus 0.841. Here the present value of output t equals to minus 1, depending upon future value of the input minus 0.841. T minus 1 is a present value, minus 0.841 is the future value. So it clearly shows that the present value of the output depending upon the past value of the input as well as future value of the input, and the system is memory, and hence the present value of the output, it is also depends on future value of the input, and the system is non-causal. Stability. For the bounded input bx greater than or equals to magnitude of x of t less than infinity, then I have to find out the magnitude of y of t. Therefore the modulus of y of t equals to modulus of x of sine t. Here what is is it a bounded or unbounded? So sine of t, always you know that sine value always varies from 0 to 1, hence x of 0, x of 1, whatever may be here, it is also what bounded, because x of t is a what bounded value. So means here t value I have to calculate. What is the t value? Here is nothing but sine t. So always sine t value varies from 0 to 1, hence x of 0 or x of 0.5, x of anything here up to 1, x of 1 is a what bounded, and the system is stable system. 15th problem. Y of t equal to t plus 10 multiplied with x of t. Bring into the standard form. System operating on the input signal is equal to input signal multiplied with t plus 10. Linearity. T of a into x1 of t plus b into x2 of t is equals to t plus 10 multiplied with input. In case of linearity, input is a into x1 of t plus b into x2 of t LHS. RHS. A into y1 of t plus b into y2 of t. Y of t is given. I have to calculate y1 of t is equal to t plus 10 x1 of t. Y2 of t is equal to t plus 10 x2 of t. Substitute the y1 of t, y2 of t here. We have a RHS. Comparing LHS and RHS, both are same. System is a linear. Time invariant. System operating on the input signal x of t minus t naught. T naught not defined in the question, hence we can consider t naught here. This is equal to t plus 10 multiplied with input. T plus 10 multiplied by input. What is the input in time invariant? X of t minus t naught. This is LHS. RHS, y of t minus t naught. Y of t is given. I have to calculate y of t minus t naught. Just replace t by t minus t naught. You will get t plus 10. T will be replaced by t minus t naught plus 10. X of t minus t naught. RHS. Comparing LHS and RHS, both are not equal. System is not time invariant. 1 minute. Okay, both are not equal. System, I written a system time invariant. This is not time invariant. Next problem, memory. Here the present value of the output depends on present value of the input, and the system is memoryless. Means the system output does not depending upon the future input, and the system is causal. For the bounded input, now I have to calculate the magnitude of y of t. The magnitude of y of t is equals to magnitude of t plus 10 into x of t. Separate this one. Magnitude of x of t is what bx. Therefore, magnitude of t plus 10 into bx at t equals to infinity, infinite plus 10, infinite into bx is a infinite, and output is unbounded. Therefore, the system is unstable. 16th problem. Y of t equal to x of t multiplied with x of t minus 1. Now convert into system properties. System operation. System operating on the input signal x of t is equal to y of t, that is equals to x of t into x of t minus 1. So the problem is defined that system operating on the input signal is equal to input signal multiplied with input signal in which t will be replaced by t minus 1. Linearity. T of a into x1 of t plus b into x2 of t is equals to input signal a into x1 of t plus b into x2 of t multiplied with input signal in which t will be replaced by t minus 1. Input signal in which t will be replaced by t minus 1. LHS. RHS. A into y1 of t plus b into y2 of t equal to a into, what is the y1 of t? X1 of t into x1 of t minus 1. A into x1 of t minus 1 plus b. What is the y2 of t? Y2 of t equal to x2 of t multiplied with x2 of t minus 1. X2 of t multiplied with x2 of t minus 1. This is RHS. Comparing LHS and RHS, both are not equal. System is non-linear. Go for time invariant. System operating on the input signal x of t minus t naught is equals to input signal x of t minus t naught multiplied with input signal in which t will be replaced by t minus 1. T will be replaced by t minus 1. This is LHS. RHS. Y of t minus t naught equal to t will be there. I have to replace t by t minus t naught. X of t minus t naught. X of t minus t naught minus 1. T minus t naught minus 1. RHS. Comparing LHS and RHS, both are same. Hence the system is time invariant. Next, memory. The present value of the output depends upon the present value of the input as well as past value of the input. Therefore, the system is memory. Here the present value of the output does not depending upon future value of the input and the system is casual. Stability. For the bounded input Bx greater than or equals to magnitude of x of t less than infinite, then I have to find out the magnitude of y of t. Magnitude of y of t is equals to magnitude of x of t, magnitude of x of t minus 1. For the bounded input, magnitude of x of t is a bx, it is a bx. Shifted version of the bounded signal is also bounded. Bx into bx is a bounded, hence the total output is a bounded and the system is stable. Seventeenth problem. Y of t equal to integration minus infinite to t x of t minus tau into dt. Now bring the given problem in the form of system operation. System operating on the input signal x of t is equal to y of t, that is equals to given as integration minus infinite to t x of t minus tau into dt d tau. So here the given that system operating on the input signal is equals to integration minus infinite to t input signal in which t will be replaced by t minus tau into d tau. In case of linearity, system operating on the input signal, in linearity input signal is a into x1 of t plus b into x2 of t, that is equal to integration minus infinite to t integration minus infinite to t input signal only we have to replace t by t minus tau. Input signal a into x1 of t plus b into x2 of t, replace t by t minus tau into d tau. This is LHS. Take RHS of the linearity. A into y1 of t plus b into y2 of t is equal to a y1 of t is here x1, y2 means here x2. Integration minus infinite to t x1 of t minus tau into d tau plus b y2 of t is equals to minus infinite to t x2 of t minus tau into d tau. This is RHS. Comparing LHS and RHS, both are same. Therefore, the system is linear. Go for next property, time invariant. System operating on the input signal. In time invariant, input signal is x of t minus t naught. Of course, t naught is not predefined in the problem. I can take t naught here. So as we know that in the given problem statement, system operating on the input signal is equal to integration input signal into d tau. In place of a input signal, t will be replaced by t minus tau. Same thing. Time invariant, transfer the input signal is equals to integration input signal in which t will be replaced by t minus tau. T will be replaced by t minus tau minus t naught into d tau. RHS y of t minus t naught. Y of t is given, I have to obtain y of t minus t naught. Just replace wherever we have t by t minus t naught. Integration minus infinite to t minus t naught. X of t minus tau. T will be replaced by t minus t naught. T will be replaced by t minus t naught into d tau RHS. Comparing LHS and RHS, both are not equal. So when I want to compare integrations, here I have to check the two cases. If limits are same, then inside the integration terms will be compared, or under the integration terms are same, then compare the integration limits. Either of the one is same, then the LHS is equals to RHS. If both are not same, LHS is not equals to RHS. So here either of these two, under the integral part, x of t minus tau minus t naught, here also x of t minus tau minus t naught. Under the integral term of the LHS and RHS are same, then I can compare the limits of both the LHS and RHS. RHS limits are minus infinite to t minus t naught. Here LHS limits are minus infinite to t, not equal. Hence LHS is not equals to RHS, and the system is not time invariant. Means the system is time variant. Go for memory. The present value of the output depends on past value of the input. Therefore, the system is memory. In the given itself, y of t, here limits are minus infinity to t. The present output I can calculate y of t from t to minus infinity. Here input is x of t minus tau. Present input x of t and t minus tau. If tau value is a positive value, it will be depends on the past input value. Hence, y of t is depending upon the present input as well as past input values if tau is positive. Therefore, the system is memory, hence the system is casual system. Why I am saying the system is a casual? Here x of t minus tau, here time shifted of x of t signal will be given, means here t is there minus infinity to t, means the present output value depending upon the present input x of t as well as past input x of t minus tau. Therefore, the system is casual, means the present output does not depend on future input value. Suppose in the problem it has given x of t plus tau I have, then the output signal depends on present input as well as past input as well as future input. At that case, the system may be non-casual, but in this case the system is what? Casual system. Stability: for the bounded input x of magnitude bx greater than or equals to magnitude of x of t or less than infinite, then I have to calculate the magnitude of y of t. Magnitude of y of t taking on both sides, we get magnitude of y of t is equals to integration minus infinity to t x of t minus tau into d tau. Take integration, modulus will comes inside the integral. So whenever input is bounded and its magnitude is also bounded, so therefore the bx take outside, integration of 1 into d tau, integration 1 into d tau is tau, upper limit minus of lower limit, you will get a t plus infinite, and the answer is infinite. Hence I can say that the magnitude of y of t is unbounded and the system is unstable system. 18th problem, y of t equal to p into x of t whole square plus q into x of t. Bring the given problem in the standard format of a system. System operating on the input signal x of t is equal to y of t, that is given as p into x of t whole square plus q into x of t. Linearity: system operating the input signal a into x1 of t plus b into x2 of t is equal to p into, the problem defined as system operating on the input signal is equal to p into input signal square plus q into input signal. P into input signal square, what is input signal? A into x1 of t plus b into x2 of t plus q into input signal a into x1 of t plus b into x2 of t. This is LHS. RHS: a into y1 of t plus b into y2 of t, that is equals to a into, what is a y1 of t? Y1 of t equals to p into x1 of t whole square plus q into x1 of t, I have written here, plus b into what is y2 of t? Y2 of t is equal to p into x2 of t square plus q into x2 of t, I written here. This is RHS. Comparing LHS and RHS, both are not equal, therefore the system is non-linear. Time invariant: system operating on the input signal in time invariant, input signal is x of t minus t naught, that is equal to p into input signal whole square, p into input signal whole square, already I told in time invariant input signal is x of t minus t naught, plus q into input signal x of t minus t naught, LHS. RHS: y of t minus t naught equal to, t will be replaced by t minus t naught, p into x of t minus t naught whole square plus q into x of t minus t naught, p into x of t minus t naught whole square plus q into x of t minus t naught, RHS. Comparing LHS and RHS, both are same, the system is time invariant. Memory: the present output depending upon present input value, and the system is memoryless and the system is casual, because the present output value does not depend on the future input value. Therefore, the system is a memoryless as well as system is a casual. Next, stability: for the bounded input, that is bx greater than or equal to magnitude of x of t less than infinite, then I have to calculate what is the magnitude of y of t. So taking magnitude on both sides, we get magnitude of y of t is equal to magnitude of p into x of t whole square plus q into x of t. Therefore, magnitude of y of t equals to modulus of p into, what is the magnitude of x of t is x, bx square plus q into bx. Bounded plus bounded is equals to bounded, hence the magnitude of y of t is a bounded, Hence, we can say that the given system is bounded input, bounded output, stable system. Thank you.